So what is an outlier? Tell me again there, Colin.
A numerical value that is excessive high or low.
A numeric value that is excessively high or low for the data. That's a pretty good generalization of what an outlier is, absolutely. Now, I know that I left you on a cliffhanger yesterday. Did you lose some sleep last night wondering what a true outlier was?
I lost so much sleep.
So much, I'm so sorry. Hurt my heart there, Danny. All right, so how do I identify a true outlier? Here's how we do it. We are going to use the 1.5 IQR rule. We're going to use the 1.5 IQR rule. So what is the 1.5 IQR rule? You guys have heard of this before, yes?
Nope.
So, number one, find the IQR. Remind me, how do I find IQR again? Q3 minus Q1. What does Q stand for? Quartile. Quartile 3 minus quartile 1. Okay, cool. So first of all, I got to find the IQR. And then what we're going to do is we're going to multiply the IQR by 1.5.
Why does that work?
I will show you visually why in a minute, but the real reason why is because some really smart statistician said 1.5 sounds about right. I will tell you that if you Google something about like finding a true outlier, some people will use 1.75, some people will use 1.25. The most accepted thing is 1.5, but you can actually, some people do different things. Okay. So we're going to multiply the IQR by 1.5. I'll show you visually in just a second what that basically does. Then here's what you're going to do. You're going to have a low outlier for any number that is less than Q1 minus that 1.5 IQR value. Any number that is less than 1.5 IQR subtracted from Q1, that number would be considered a low outlier. So if I take Q1, subtract 1.5 IQR, anything less than that is a low outlier. What about a high outlier? Higher than what?
Maybe just quartile 3.
Quartile 3, okay. So a high outlier is going to be anything that is greater than Q3 plus 1.5 IQR. This is how I can tell if I have an outlier. A real one. Mathematical. All right, let me show you guys a picture that will kind of put this in perspective for you. So let's say this is my box. Okay, it's a very nice symmetrical box here. Obviously, from the left side to the right side, this is the IQR, obviously. Now, if I take the width of that box, okay, which is the IQR, and I go 1 IQR, so one box, plus half of another box. That's going 1.5 IQRs away from the box. So basically, if I take that box, whatever the width is of the box, and I go 1 box, would you say that's about 1-ish? Is that about how far it is? There you go. So there's 1, and then half of it, there's 1.5. Anything lower than this, these are going to be low outliers. So 1 IQR and then half of an IQR. That's basically what we're doing when we are doing 1.5 times IQR. and subtracting it from Q1. Then we do it on the other side as well. We basically say, okay, 1 IQR, so that's about the width of the box, and then half of the box, there's about half of an IQR, and anything outside of that would be a high outlier. So that's kind of visually speaking what we're doing, okay? Yes?
What if it's inside?
If it's inside of that, then it's not considered an outlier. Yep. So, and again, those are not the whiskers per se. That's just like 1 IQR and then half of an IQR. That would be my low outlier, and that would be my high outlier. Cool? Cool, let's do it. Let's do an example. Don't you guys like examples? So we talked about how to make a box plot. We talked about how to identify a true outlier. We talked about the 5-number summary. Now let's put it all into practice. Are you ready? Here we go. How many goals? Here are the data of the number of goals scored in the 16 games played by the 2016 U.S. women's soccer team. Notice there is an even number of values in this data. Are you ready? We need to calculate the 5-number summary and then find the IQR. What is the minimum? What is the maximum? We need the median. What is the median of this data? Find the median.
It's 2.5.
Because it's an even number.
When you start going back and forth, trying to find, you end up with these two numbers left over, right? And so what do you need to do in order to find the median? Find the average of those two numbers. What's the average of 2 and 3? All right, so the median of this data is 2.5. Now, here's the cool thing. We have now cut the data literally in half. There are 8 values on the left. There are 8 values on the right, okay? So now we have a lower half and an upper half. Now we need to get Q1. How do I get Q1? Find the median of the lower half. So find the median of the lower half. Go. 1.5. It is between 1 and 2, so Q1 is 1.5. Very good. We need to find the median of the upper half. What is it? 5?
Yes.
Yeah.
Wait, was that? Oh. I was like, I thought it was.
Q3 is 5. Very good. Now we're going to write the 5-number summary. What is the minimum?
1.
What is the Q1? Median. Q3. Maximum. Very good. There's the 5-number summary. Any questions? What is the IQR? First of all, how do you find the IQR?
Subtract 3.5.
Q3 minus Q1. What is Q3? 5. What is Q1? What is 1.5 or 5? Sorry, 5 minus 1.5? 3.5. The interquartile range is 3.5. I have a question for you. What is the range of the middle 50% of this data?
With the range is one number.
Jensen's correct. It is 3.5. I just asked you what's the IQR. I just asked it in a different way. IQR is the range of the middle 50%. So what is the range of the middle 50% of this data? 3.5, which is the IQR. Cool? So fun. I love stats too. All right. Are there any true outliers in the women's soccer goal distribution? What are we going to utilize in order to find that out? The 1.5 IQR rule. All right, 1.5 times that IQR of 3.5. Does anyone happen to know what 1.5 times 3.5 is? 5.25. Woo! 5.25. That is the 1.5 IQR value. Everybody good? Perfect. Now what are we going to do with that 1.5 IQR value?
Add it to Q3.
We're going to use it to find the fences. All right, so we're going to take Q3 and we're going to add 5.25. We're going to take Q3 and we're going to add 5.25, which is the 1.5 IQR value. What was Q3? 5. What is 5 plus 5.25? 10.25. What have you just found? This is the upper fence. This is the upper fence. Is there any number in our distribution that is bigger than 10.25? What is it?
13.
Guess what? 13 is an upper outlier. 13 is an upper outlier. Now, ladies and gentlemen, I will never use the upper fence again in this problem. It has done its job. It is no longer useful. It does not need to be displayed on the box plot. It is just there to identify outliers, and then it's done. Got it? Perfect. All right, how do I find the lower fence? Q1 minus 1.5 IQR, which is, what was Q1? 1.5, wasn't it? Wasn't Q1 1.5?
Yes.
Okay. 1.5 minus 5.25. 1.5 minus 5.25. Oh boy! What's the lower fence? This Miss Lakey. Yes, ma'am. Thank you. Goodbye, Ava. Negative 3.75. Now, is there any value in our data that is less than negative 3.75? I should hope not, since this is scores gold by the soccer team, right? So, this negative 3.75 was our lower fence. Because there are no values less than that, what do we know about the lower outliers? There is none. No lower outliers. Perfect. How we feeling?
If the number is like exact.
If the number is exact, it is not an outlier. It has to be actually bigger or smaller than the fence. So it has to be greater than or less than, not equal to. Very good. Yes?
If it's like bigger by 0.5, then it's still an outlier.
Say that again?
If the number's bigger like 0.5, then it's still an outlier.
Yeah, if it's bigger at all, like by any amount, yes. Have a great day. All right, we're going to now make a box plot of this data. Are we ever going to use that lower fence again?
Never.
Never, ever, ever. We're done with it. It did its job, okay? Make a box plot. Here we go. Step 1, we're going to make a number line. Well, that was fun. Next, we are going to mark where the Q1, median, and Q3 are with a vertical line. Where was Q1? Q1 was 1.5. What was the median? 2.5. What was the Q3? 5. I mark them and I turn them into a box. I mark them and I turn them into a box. All good?
Yep.
I need to now draw my lower whisker to the lowest non-outlier value, which happens to be the minimum in this case. What is the minimum? 1. So there's my whisker. It goes from the box to 1. Now, I need to draw my upper whisker to the highest non-outlier value in the data. 10. A lot of people want to draw this to the fence. The fence already did its job and we're done with it, okay? We go to the highest non-outlier value that's actually in the data. Does that make sense? Perfect. And then what's the last thing we need to do?
Smiley face on the 13.
You want a smiley face? Okay, all right, that's cool. There you go.
Shape, outlier, notice, bro.
We did not label our x-axis. We have to label our x-axis. What does the x-axis represent? The number of goals. Hashtag goals. Number of goals. Do you guys feel pretty good about making a box plot? Well, then let's do it again. Here are the data on the number of goals scored in 15. There's an odd number of numbers. Goals scored in the U.S. men's soccer team.
Median's 4.
What is the minimum?
1.
What is the maximum?
11.
All right, what is the median? Now, let's be careful here. Which 4 is the median? The first 4. Okay. Now, this guy right here is the median. That, because of the fact that we have an odd number of numbers, that number is now the median, and we no longer use it when we're trying to find the median of the lower half and the median of the upper half, okay? So this median is kind of like by itself. It's doing its own thing. And now we're going to find the median of the lower half to get Q1 and the median of the upper half to get Q3. That's slightly different than how we did it a second ago when we had an even number. Does this make sense? Yes.
So it's only when it's odd?
Only when there's an odd number of numbers are you going to have this situation, yes. But a lot of people try to put the median with one or the other, but you don't. It's by itself.
Later, I thought this was AP day.
It's actually going to end up being tomorrow. I'm sorry. Okay, what is Q1?
2.
Which 2?
The left one.
So Q1 is 2. What is Q3? Which one?
So it's further
Right
5.
one.
Starting.
Okay. What is the 5 number summary in order from left to right? Go.
1, 2, 4, 5, 11.
You go great.
Okay, IQR. How do you calculate the IQR? What is Q3?
5.
What is Q1? What is the IQR? Ladies and gentlemen, what is the range of the middle 50% of this data?
3.
Thank you. Do you guys have any questions so far? Are there any outliers? Let's find out. Let's find out if there are any true outliers by using the 1.5 IQR rule. What is 1.5 times the IQR of 3? Okay, 1.5 times 3 is in fact 4.5 in most circles. Now, what do I do with that 1.5 IQR value?
Add it to Q3 and subtract it from Q1.
Okay, I am going to take 4.5 and I'm going to take Q3 and add that 1.5 IQR value. So, what was Q3?
5.
Q3 was 5, and I need to add 4.5. What is 5 plus 4.5?
9.5.
9.5. What is that called?
Upper fence.
That's the upper fence. Now, are there any numbers in our data that are bigger than 9.5?
Yes.
What are they?
11.
11. Guess what that means about 11?
It's an outlier.
11 is an upper outlier. Eleven is an upper outlier. What about that 9.5 now? I'm done with it. It's crap. That's right. I don't need it anymore. Very good. All right, what do I do next? I like that. Find the lower fence. Find the lower fence. We're going to take Q1 and subtract the 1.5 IQR value. What is Q1?
2.
It was 2. and I want to subtract the 1.5 IQR value of 4.5. What is 2 minus 4.5? Negative 2.5. Is there any lower outliers? No lower outliers. Do you guys have any questions about finding the 5-number summary, the IQR, or any true
I have
outliers?
a question. I just need like some reassurance on how to find the IQRs.
Q3 minus Q1.
Gotcha.
Equals IQ.
Alright. I got it. Thank you.
Because like, if the minimum is always 1, is there like never gonna be
No. Not necessarily. It could be that your minimum is 1 and maybe your data is a little bigger than that. And so it could be that this data is about things that are low numbers. Okay? So, but like let's say I have a data set that is about, I don't know, average number of pencils in a backpack. You know, like maybe those would be a little bit higher numbers or something. Then maybe one could end up being an outlier. It just really depends on the data. So
Could it be a negative number?
what?
Like the minimum?
Yes, the minimum can be a negative number. We will have data that has negative numbers in it, and that's okay. Yep, for sure. Good questions. Very good. All right. We are now going to make,
Max is 0.
what are we going to sketch?
Parallel box plot.
Whoa, what are we going to sketch? What does it mean to make a parallel graph?
Make it parallel.
But what do they share?
The same x.
They're going to share an x-axis. Very good. They're going to share an x-axis. So I need another x-axis. Now we are comparing, making parallel box plots of the men's data that we just analyzed and the women's data, which we actually already made a box plot of, but we're going to redraw their box plot here. So I need my x-axis to cover all the data for the men and the women. So that's why you have an x-axis here from 1 to 13 again. Because I need to get the women's data on here again. The women's box plot's going to go on here again. Alrighty. Do you guys want to put the women's box plot first, or do you want to put the men's box plot first? Men's? Okay, that's fine. What is the men's Q1?
2.
What is the men's median?
4.
What is the men's Q3? Make that into a box. How low should the lower whisker go? 1. How high should the upper whisker go for the men's data? 7. 7 is the highest non-outlier value in the data. The fence is not used. The fence just was used to identify an outlier. All right, anything else we need for the men?
Yes.
What do we need?
Outlier.
How do you want to mark it?
Star. Smiley face.
There you go. Really doesn't want me to use the smiley face. That's when it loses connection, is when I try to do a smiley face. Oh, that's weird.
It doesn't want joy.
It does not. I understand. All right. I don't know. All right, kids. There's our men's data. Now, in order for this to be a parallel box plot, I need for the women's data to be here too. So I need to redraw the women's box plot right above the men's box plot here. So let's do it. 1.5 was our Q1. 2.5 was our median. 5? No. Yes? 5 was our Q3. There's our box. 1 was our lower value, our minimum. 10 was our upper value, our upper whisker. And then we had a whole big happy face there at 13.
You got pizza.
Has to be Grace. Has to be.
Hi,
Hi,
I
Grace.
come bearing gifts.
All right, put them over there, or that
Over there?
Yeah, that's fine.
Cool.
I mean, that's great. All right, cool. Do you guys have any questions about this?
No.
Got it? All right, now we need to compare the distributions. Compare the distributions. What do you guys think about the shape of these distributions? Okay, this can be a little bit tricky. Okay, so let me show you guys how to tell shape of a box plot. You ready? We have symmetric distribution. Where is the median in a symmetric distribution? In the middle.
Paper, what's on that paper? Yeah.
A right skewed distribution. Approximately where is the median in a right skewed distribution?
In the
It's a little bit to the right of the peak, okay? In a left skewed distribution, approximately where is the median? A little to the left of the peak. Do you guys notice a trend here with the median and the peak? They're always pretty close to each other, right?
Yeah.
So watch this. Here's my box plot.
Is that like a Sharpie pen?
This in the middle is the median, which will be about close to the peak, right? And now if I draw a line to the minimum and a line to the maximum, do you see the shape? What is it?
Skewed right.
Skewed right. Very good. Do that again with the men's data here. About the peak, I'm not saying it's exactly there, but for estimation purposes, the peak is about where the median is. I go to the low, I go to the high, and what shape do you guys think that distribution is? Also approximately right skewed. So when I'm comparing these two different distributions, I can see now that both of them are approximately right skewed. Both distributions are approximately right skewed. Any questions about that? Oh no, you guys, we made a very terrible error.
Didn't label the x-axis.
I did not label the x-axis. Even more than that, something else is missing.
I labeled it exactly.
What if someone walks in here for the first time and they look up here, which one's which? They don't know. There's no key. So we're going to throw a W for women and an M for men. Now we've got a key. Yeah, you do. All right. Outliers. So we've compared the shapes. They're both right skewed. Outliers. How would you guys write a sentence if I asked you to write a sentence comparing the outliers of these two distributions?
They both have upper outliers.
They both have upper outliers. Men at 11, women at 13. Boom. That's how you could compare their outliers. Any questions about that? All right. Perfect. Center. Look at the box plots, you guys. What seems to be the most obvious choice for the measure of center that you should use?
Median.
The median. Why?
Because we already found it.
It's right there. Like literally the median's already marked for you. Why would you go back and try to find the mean when the median's literally right here for you already? Who would do that? Not anybody smart. So, if I want to compare the centers, what would I say?
Guys have a
The guys have a higher.
The guys have a higher median than the girls. There you go. The guys have a higher median than the girls. Finally, spread. What would I say in regards to spread? What might be our comparison for the spread of this data? What would you say?
They both start at 1, but
They both start at 1. However, which spread is bigger, the men or the women? The women have a larger spread than the men. You got it? Questions, comments, thoughts, concerns, feelings?
I'm concerned.
Always. All right. Moving on. Box plot shapes can be a little tricky, but I think you guys are smart enough. You got this figured out. Look at the top left here. Imagine the peak. And what shape do you think that is? Just say left skew. Very good. Skewed left skew, same thing. Just doesn't matter. Top right over there, test grades. Class 1, the top box plot. Approximately what shape do you think that one is? That's probably approximately symmetric. I'm going to agree with you on that. All right. What about class 2? Which way? What? Yeah, I would say this is a left skew. Maybe slightly left skew, but left skew. Any questions? Got it? Cool?
Are we gonna like mathematically find some miscues?
Here's what you can, as far as mathematically finding skew, the only way to mathematically find skew is to find the median and the mean and compare them. That's how you mathematically find skew. All right, what about the Best Actress Award winners? What do you think the shape is of that distribution?
Right.
Yeah, I would definitely say this is a right skew. Very good. Oh my gosh, you guys, our box plot fell over.
Oh
No.
Better pick it up.
I know, we better pick it up. Let's go. So, what do you guys think is the shape of this distribution? Why do you think right skew? Why not left skew?
Because you have to start from the lowest value.
You've got to go from lowest to highest. Man, Jensen's just a genius. This is right skew. Okay, I'm going to give you 30 seconds. 30 seconds to label the last 5 box plots. Go.
Live recreation of what they did to the poster. They took the poster and they crossed out this, and the fist, and because they said the fist means black power and they don't like black power.
Okay, wow. All right, love that.
Yeah, I love the administration.
It's greatness. All right, you ready? You got them all now? Not yet? Okay, I'm sorry, my bad. My bad!
No, because look, what's the point of it? There's that second one left.
Okay, here we go from left to right. What is the shape of the graphic novel distribution? Probably approximately symmetric, I would agree. What is the shape of the humor distribution?
Left.
Left skew. You got to look at it from lowest to highest, left to right. So in this case, we got to look at it this way. So it's left skew. Okay. What about the third one and the one in the middle? Graphic memoir.
Right skew. Right.
Yeah, I'll go with right skewed. Okay. What about nonfiction? Approximately symmetric. What about the last one? Okay. Do you guys have any questions about box plots?
Never.
Are you good?
Yes.
All right. Are you ready to learn about the hardest thing ever in life? Standard deviation, bruh. No. We're just gonna do a short little intro to it today, and then we'll finish it tomorrow.
As soon as you're done talking, I start an infomercial. So.
Oh, dang. Y'all don't want me to stop talking. All right, so here we go. Standard deviation. So what time would I get to school if I told you guys that I will be at school within 5 minutes of 7 a.m.?
Either 6:55 to 7:05.
Okay, I'm going to get to school somewhere between 6:55 a.m. and 7:05 a.m. That is on average, okay? That means that I am basically going to be here at 7 a.m. plus or minus 5 minutes. Okay? Okay.
Is that you?
Nice. Dang.
Does that mean that I will never get here earlier than 6:55?
No.
Does that mean I never get here after 7:05? What are these numbers? These are averages. On average, I get here at 7 o'clock, And on average, that typically varies by about 5 minutes. There are times that I get here earlier than that or later than that. But this is an average, okay? That give or take, that 5 minutes, that is standard deviation. Standard deviation is the give or take from the mean. It's how much does the data deviate on average from the mean, okay? So what does standard deviation measure? Standard deviation, you can abbreviate it like Saint Dev, or you can also use a capital S, capital D. Either way is very accepted. Standard deviation is the average distance from the mean. Standard deviation is the average distance from the mean. Here is an example of the lazy person's way to do standard deviation. It's pretty close, and it helps you to understand what it is. All right, here's your data set. 1, 2, 3, 4, 5. I would. I mean, it's up to you, but I would. 1, 2, 3, 4, 5 is our data set. What is the mean of this data set? 3. Okay, so X bar equals 3. Remember X bar? X bar, it's a great guy. All right, the average of this data set is 3. Are you with me so far?
Yep.
Okay. I now want to find the distance from that mean to every value in the distribution. What is the distance from 3 to 1? 2. What is the distance from 3 to 2?
1.
What is the distance from 3 to itself?
0.
What is the distance from 3 to 4? The distance from 3 to 5?
2.
Okay, what have we just found? We have just found the distance from the mean. We found the distance from the mean of each individual value. But what does standard deviation measure? The average distance from the mean. I have the individual distances, so what can I do? Average these. So let's average these 5 numbers, these 5 distances. What is 2 plus 1 plus 0 plus 1 plus 2? 6 divided by 5. There are 5 numbers here. What is 6 divided by 5? 1.2. Ladies and gentlemen, this is the standard deviation. On average, this data varies from the mean by about 1.2. Sometimes it's more than 1.2. Sometimes it's less than 1.2. But on average, it deviates from the mean by 1.2. Notice, please, that the majority of the data is within one standard deviation. Okay? So my X bar plus or minus my standard deviation would be 3 plus or minus 1.2. And the standard deviation tells me what is a typical deviation from the average. A typical deviation is somewhere around 1.2. Are there some that are more? Absolutely. Are there some that are less? Absolutely. But on average, we will typically deviate by about 1.2. That is the easy, lazy way to understand standard deviation. Does it make sense at this moment? Well, come back tomorrow and we'll do the complicated way.